Hello, I'm Andrea Gallo. I'm the director of the enterprise group at Linaro, and I will be talking today about running OpenStack on ARM. I will be reusing the same slides that I gave with my speech at the CloudOpen conference in Chicago, hosted by the Linux Foundation last August the 22nd. I will skip the first next slides, which are about an introduction about ARM, as I am assuming that you are all aware of what the ARM company and IPs are. So let me start with a short overview about Linaro. We are a not-for-profit company, and we focus on collaborative software engineering. We are funded by our members. Linaro was started in mid-2010 by 6 companies who wanted to host, improve, and foster the development and optimization of Linux on the latest ARM cores. Linaro has since then expanded to a significant number of members. And from a core to also expanded also into several segment groups. The idea overall is always that we focus on solving common problems through collaborative engineering. Instead of having multiple companies solving the same problem, every company their own way, without cooperating and eventually sharing their software as open source only at the end. The idea is that all these companies cooperating through Linaro, they get the same problem solved once for all, and this allows to share the development costs among all companies and improving and reducing the time to market. All the work is carried out in the open. It is tested and then upstreamed. So the work appears immediately on the Linaro public Git repo, and then it moves into the corresponding open source projects when it is accepted mainline. So kernel.org, AOSP for Android, etc. The Linaro engineers all contribute to the open source projects. And if we look at the kernel contribution by company, Linaro has been steadily into the top 10 for the last few years. If we look at the last numbers from August 2014 for the 3.16 kernel, Linaro ranked as number 4 as a company contributor. In 2010, Linaro started a Linaro Enterprise Group. This is all around building the ecosystem for ARM servers. This was the work about servers started when a bunch of companies contacted Linaro, contacted us, proposing to share costs and development around enabling the ecosystem for ARM servers. With a primary goal of focusing on standards, avoiding fragmentation, and then enabling and optimizing workloads and core libraries. Since the beginning, we have been focusing on 2 parallel tracks. So the first engineering effort has been on enablement. As you can see from the slide, we have been focusing on enabling the foundation technologies for servers. So we have focused on UEFI and ACPI as the standard foundation blocks. We're really excited that the UEFI forum also is now hosting the ACPI specification, and Linaro and other companies are now contributing to the new ACPI specification. We have been working in improving the integration between Linux and the Tiano Core open source project for UEFI. We have worked on improving the integration with runtime services. We have cleaned the Tiano Core 3 for ARM, and especially now the UEFI Tiano Core can boot a Linux kernel as a native EFI application. There is no custom Linux loader for ARM anymore. It's just like on other architectures. We are excited about ACPI. Thanks to the new specification, the ARM processors are now properly supported, and we are able to boot many platforms, many ARM v8 platforms with ACPI without any device tree. We are in the process of reviewing all the patches with the key maintainers, both ARM maintainers and the overall Linux ACPI maintainers. We have been working also on hypervisors. We have a strong cooperation with Citrix on Xen, with the Xen project tech leaders, and we also have a significant contribution on KVM in cooperation with ARM. We have also been focusing heavily on OpenJDK in cooperation with Red Hat. We have developed a very high-performance OpenJDK just-in-time compiler. We released the C2 compiler for ARM 64-bit last April. We are now in the process of upgrading to OpenJDK 9, as our JIT is now tested with both OpenJDK 7 and 8. The last canonical Ubuntu trusted release provided the first official support for ARM 64-bit servers and is including the OpenJDK JIT. Then we have a second track of activities on the engineering side, and this is about workloads. Again, cooperating with Canonical and Red Hat, who are both members of the enterprise group, we have been using pre-built packages from both distros, from the open source releases of Fedora, the Fedora project, and Ubuntu. And we have been testing workloads, profiling them. So we have LAMP stack. We have tested memcached, HA proxy, nginx, PHP, Python, and we have verified that all these workloads run as smoothly as on other architectures. I'm not talking here about raw performance. I'm not allowed to share numbers about raw performance at this moment, but I'm talking about test cases where the CPU is fully loaded, and then we can evaluate and study the distribution of the software functionalities per CPU. So we can compare the breakdown of the software functions and verify that in percentage the CPU is taken by the same function by a similar amount of time on ARM and on other architectures. So this shows that the software stack for all the web server stack is mature and works equally well on ARM and on other architectures. And the optimizations we have been working on are on the core libraries, OpenSSL, CRC computation, and similar. We also have OpenStack running. We have been cooperating again with Ubuntu, with Red Hat, and Canonical. And how OpenStack runs on ARM is the topic of my speech. We also have Hadoop running. We are running the TerraSort benchmark on top of our OpenJDK as one of the release testings. So the presentation, my speech is all about OpenStack and cloud, and this speech was for the CloudOpen conference. So, well, moving on to the next slide, this is time now for some cloud stuff, I guess. Enough for the introduction on Linar and the enterprise group. When we talk about cloud, as you can see in the next slide, the key terms are all services: platform as a service, software as a service, infrastructure as a service. And I guess that most of us are aware of what this really means. But I looked on Wikipedia, and if you look at the next slide, Look at how many services you can have. It's huge. So this means that cloud is a revolution. It means that there are so many options and different ways of offering services. So it's really complex and can be daunting at times. So let me try and give a very short positioning of which areas of services we're looking at with ARM. So moving on the next slide, let's start with one single remote machine, as the old days when from a client an engineer could access a remote server for some remote computing. The next step is to add few more remote machines. But when you add more, then it doesn't scale. It's not sustainable. This is where the transition from a traditional old-fashioned, I would say old-fashioned now, not traditional anymore, old-fashioned network, computing network, this is where we see the transition from this to the cloud. So let's move on with the slide, and let's go back to the situation where there was one single control point. Thanks to this single control point, then you can add 3 more nodes with the next slide. The key point is that on these nodes, then you can run multiple virtual machines, moving to the next slide, and on every virtual machine, moving on, you can add multiple runtimes. So you have multiple runtimes on every virtual machine and multiple virtual machines on servers. So the point is that now on these runtimes, you can run the web applications, the web services. You can have a runtime for PHP, a runtime for Python, a runtime for Java, and so on for Ruby, and you have applications. So Gmail, Google Drive, eBay, PayPal, you can even have the Office suite, the 365. All these are web services. So if we go back to the terminology, you see that the applications, these are what we refer to as software as a service. The gears, the runtimes that allow to develop applications. This is the platform as a service. And from the virtual machine down, this is the infrastructure. So this is infrastructure as a service. And this is what OpenStack, KVM, Zen, and new technologies like Docker, this is all what they are enabling. They are enabling, well, Docker is a little bit higher in the enabling platform as a service. So it's all about deploying machines and deploying software services for the end users who develop the application that you use as services on the web. So let's now look at the next slide, at the OpenStack architecture, as we need to focus on OpenStack. I tried to find one slide summarizing the OpenStack architecture. This is the official one from the OpenStack documentation. I guess this is pretty complex, difficult to read, and maybe scaring to someone. So I tried to look for more, and on the next slide you can see the OpenStack conceptual architecture, which is better, but still maybe too much engineering. So if we move to the next, this is the OpenStack software diagram, and this is coming from the official OpenStack web pages. I think this is simpler, good enough for a chat like this we are having together. But I have found one more, the next one, which I think is perfect for our context. This is showing the OpenStack modules. So everything starts from the dashboard, the Horizon project, where from a web UI, of course you can use also command line or automatic connections via the internet. But let's assume that an operator connects to the dashboard and can request a virtual machine. So first of all, there must be some identification to provide the services, and this is through the identity module in OpenStack. This is Keystone. I guess this can be used also for billing by cloud providers, but well, let's not delve into the commercial side. If we look at the other modules, compute Nova is the key one, which is providing you with a virtual machine. So you request for a given CPU configuration, a given amount of RAM. This is provided to you from the compute module. Then you want to select a given OS distribution, OS image, and this is provided by the image service, by the Glance project, which is a catalog, as the icon itself shows. It's a catalog of DVDs, Blu-rays. It's a catalog of images that you can copy into the storage part of your machine that will be loaded at boot time. Swift, the Swift project, the object storage module, is providing persistence storage for your files. Underneath, the object storage relies on blocks, on block storage. That is the file system, and that is provided by the Cinder module, the Cinder project, the block storage module. And then there's networking. Quantum, which provides, well, that's another foundation block. This provides the connection to the internet for you to access your machine. So what about ARM and OpenStack? Well, we have ported it, and if you look at the next slide, we have all the components running on ARM 64-bit servers. We have compute, we have image, object, block, identity, dashboard. The only one that we have not started working on yet, that's networking, Quantum. Why? Because we are using the Nova network, that is the networking functionality within Nova. And if you look at the OpenStack documentation, you will see that when you start a port on OpenStack, well, start with Nova network. When you need more advanced functionalities, then you can move to Quantum. For us, just for a simpler development porting path, we started from the Nova network. But we will be moving to Quantum quite soon. We're also following the evolution of the Quantum project, which is newer compared to the others. So moving to the next slide, how was this possible? This is thanks to long cooperation with Canonical and Red Hat engineers. We are using pre-built packages from DevStack, from Ubuntu. We are leveraging on the lib kernel, and we're also leveraging on the KVM work done at Linaro and in cooperation with ARM. We are running these on real ARM 64-bit hardware. This is the Applied Macro X-Gene platform. And we are also running all the applicable Tempest tests. We also have other ongoing activities. These are around moving on from DevStack Ubuntu also to Packstack and Fedora, and similarly moving on with LibVirt on Zen, which is ongoing as we speak now. So moving on, what's the effort and cost to achieve all this? I would like to spend a few minutes to put things in perspective. To look at other open source projects first, and then look at the effort for ARM versus the OpenStack project. So first, I want to briefly discuss about how OpenStack is seen as an open source project. I will be using statistics from the holo.net website, which I've always found pretty amazing over the years, and this is now owned by Black Duck. If you want, the Holo website provides also information using the COCOMO model that provides also an estimate cost of development for every open source project. So let's move on. Let's look at the OpenStack lines of code. OpenStack is about 3 million lines. That includes comments, blanks, and real source code. If we look at just source code, this is about 2 million lines. So 2 million lines. And commits per month is the next slide. So this shows the number of insertions, deletions, changes every month. And here you see that we are between 5,000 and 7,000 commits per month. How does this rate with other projects? Is it small, big? So let's compare with other projects. Let's look at the next slide. This is Hadoop. So Hadoop is 2.5 millions of lines of source code. So OpenStack, we said that it's 2 millions, and Hadoop is 2.5. So they're pretty close. There's a difference. Hadoop started in 2007. If you remember the slide that I have just showed about OpenStack, well, OpenStack really picked up in 2010. The first official commit was 2006, but the chart was showing that 2010 was when the OpenStack commit started growing, while, as you can see, for Hadoop, this started in 2007. So Hadoop has a similar size, but started 3 years before. And what about the commits per month? So this is the next chart. 200, maybe 300 commits per month. And if you remember, OpenStack commits per month was between 5,000 and 7,000. So here we see a difference. We see two projects, similar size. One started 3 years before, but they have the same size. But one is changing as 300 commits per month, Hadoop. OpenStack, close to 7,000. This is a massive difference. Let's continue comparing. Let's look at the next one. This is the Linux kernel. 17, 18 million lines of source code. This is huge, and started in 2002. This is huge. What about the commits per month? Next slide. 7,000. 7,000, like OpenStack. Let's look at another project. The next slide, Chrome. Chrome is 8, 9 millions of source code, of lines of source code. And if you look at the commits per month, the next slide, 5,000. Let's now move to the next one, comparison, where I have included other projects as well. I have included OpenJDK 8. I have included MongoDB. So let's look at the size. OpenStack 2 millions is similar to Hadoop, much bigger than MongoDB, which is one important, very important open source distributed database, and smaller than OpenJDK, much smaller than Chrome. Let's not even talk about the kernel. So OpenStack is a very new project, pretty small. Well, relatively small, because it's still 2 million lines of source code, which is not negligible. So it's already a complex project. But if we look at the commits per month, average of 4,000 with a peak of 7,000, that puts OpenStack in the same league as the Linux kernel. Now, if you go on the OpenStack website and you look at the logo, well, you will read OpenStack, the cloud operating system. That's not marketing. Now you see it. It's not marketing. The OpenStack cloud operating system. It's growing at the same pace as the Linux kernel. So OpenStack is relatively small, very complex, growing at an impressive pace. So what about OpenStack on ARM? So let's move on. What about OpenStack on ARM? What's the cost? How have we achieved that? Some of you may remember Happy Days, the old days of Happy Days. And the jukebox was not starting, and it needed a heat with Fonzarelli's Fix. And you may also remember those jokes about the car making a strange noise, and that was fixed by the service center by giving a nice heat with a hammer. And then you ask, why is the bill so high? $5,000 to fix the car, just heating it. And the joke was about giving the heat for free, but the cost is knowing where to heat. And on ARM, it's the same. Let's move on. Let's look at the patches. To run OpenStack on ARM, this is only 5 patches, 5 very small patches. So it's for free, but you need to know where, and that's the important thing. The knowledge that you need to understand where to apply small patches. I was really hoping, when I prepared this chart, I was really hoping of having 3 patches only, because I wanted to have a nice logo and say OpenStack on ARM is as easy as 1, 2, 3. But no, I have 5, so sorry, five patches. But let's look at them. Technically, 4 slides, 4 patches are about LibVirt. So LibVirt is the virtualization, the library to activate the hypervisors for virtualization. So technically, it's not OpenStack. So first of all, I would like to thank a lot Cole Robinson at Red Hat, maintainer for LibVirt. He really helped us a lot in quickly fixing minor glitches in LibVirt for KVM, which was kind of hard-coded for other architectures. And Cole knew where to fix it. Again, remember, one hit of a hammer in the right place. So Cole very quickly, in a couple of hours, he helped us achieve these patches. But technically, this is not OpenStack. If we look, OpenStack is only one. That's the next slide. Only one patch. 114 lines in Nova. So now I'm proud to say that running OpenStack on ARM is one single hit of a hammer in one place, the right place. And I would like to thank the engineers at Canonical for their contribution in helping us identifying fixes. So if I summarize, OpenStack is at the heart of the cloud revolution. OpenStack is well architectured, very well. It runs easily on ARM with just 114 lines of changes. Kudos, lots of kudos to the OpenStack architects. This is really impressive. We have seen that OpenStack is evolving at such a fast pace, as fast as the Linux kernel. So this means that you cannot work on OpenStack alone. You need to be part of a community, and you need help from the experts. So Linaro fosters the open source collaboration on ARM. The Linaro Enterprise Group focuses on ARM servers. So we are there to help you be part of a community around OpenStack on ARM. And when it comes to commercial services, product quality delivery, customer support, then you need help from Linaro members and partners like Canonical and Red Hat. Thank you.